Hi, I'm Lindsay.
And I'm Marshall. Welcome to Tumble, the show where we explore stories of science discovery.
Today, we're talking about how we see with our eyes and our brains.
Wait, we see with our brains? How do we do that from inside the skull?
When it comes to vision, our eyes and our brains work together, but how they do it is still a mystery. We'll find out how scientists are on the case. Our question today comes from Tumble listener Junie.
Hi, my name is Junie. I'm 9 years old in 4th grade. I would like to know how vision works.
Well, that sounds like, I don't know, like a difficult question to answer. How does vision work? I actually don't know. I just see stuff.
Yeah, and then what happens?
I don't know. Sometimes it hits me in the face, sometimes it doesn't.
Well, Junie already had an idea.
I think vision works by your eyes taking a photo of your surroundings, and it's upside down, and they send it to your brain, which the brain's like, hey, shouldn't that be right side up? So they turn it right side up, and that's how you see.
So Junie thinks that the eyes work just like a camera, which is why my brain is always going click, click, click whenever I blink my eyes.
Well, let's ask our listeners what they think. How do you think vision works? And how would scientists find out? Think about it, because we'll be back with a scientist who studies how the eyes and brain create vision together. So to answer Junie's question, we talked to a neuroscientist who studies how vision works.
My name is Lucas Nadolskis. I am originally from São Paulo, Brazil.
Lucas researches eyesight to invent new ways of seeing.
We try to find ways in which we could make blind people have some type of vision.
Wait, is he talking about like Geordi LaForge's visor? Are we finally making that?
You might want to explain that reference for anyone who's not a Star Trek fan.
What? Such people exist? Anyway, Geordi LaForge in Star Trek The Next Generation is a character who is blind and has a visor that helps him see.
I don't know if it's anything like Geordi LaForge's visor, but Lucas does work on technology that can give a type of vision to people who are blind. And Lucas happens to know all about technology that blind people use.
At the age of 6 months old, I was diagnosed with retinoblastoma bilateral, which meant that at the age of 5, I became totally blind.
Retinoblastoma is a cancer of the retina, which is a really important part of the eye. Lucas explained to me how the retina works together with the other parts of the eye.
What is the function of each part of the eye? We know that pretty well. Your eyes are not that different from the lens of a camera.
Oh, cool. So it's just like Junie thought. So he's talking about like the glass part on the front of the camera being like the eye, hopefully not literally.
Junie was definitely on the right track. Light arrives at the retina.
The retina is just a very, very, very thin layer of cells in the back of your eye.
Okay, so the light travels through the front of your eye to the retina, and then what?
And when your retina captures this light, it converts into a language that the brain can understand. And that's vision.
Wait, vision is a language that the brain can understand? I never thought of it that way, but that's an interesting way to think about seeing.
Right. And like Junie said, it's not just about the eyes. It's about the brain getting that signal from the eye and then figuring out how to recognize what it's seeing.
Okay, so now that light's been translated into brain speak, or brainies. Brainian, I like that. Okay, so once it's translated into Brainian, how do you understand what you're seeing?
So that's what Lucas works on. He's trying to understand the brain part. Scientists know the eye's role pretty well, but they're still studying how the brain does its part of the whole vision job.
That's the part that we really struggle to understand, because vision is such an important aspect of the human brain.
In fact, vision takes up a lot of headspace.
The part of your brain responsible for vision is by far the largest part of your brain. Most energy is used for vision.
Wait, so most of your brain's energy is used for vision? That's a lot.
Yeah. And Lucas says his work on restoring vision doesn't even focus on the eyes. He's just working on figuring out the brain because that's where vision really happens.
Okay, but if he's trying to figure out how people can see using just their brains, that sounds really complicated. Like, where do you even start?
Well, we'll find out about the first step of seeing without eyes after we give our brains this quick break. We're back. So we've been answering Junie's question about how vision works. And now that we've learned that there's a lot more to vision than meets the eye, we're going to find out how Lucas is figuring it out by hearing what's going on inside the brain.
So I guess a quick question before we get into the research. So is that true if you're blind too? Do blind people keep using the visual parts of their brain even if they're not seeing?
That's a great question. Lucas thinks that the answer is yes, because even with your eyes closed, you're using what Lucas calls visual perception. You're imagining what things look like.
I think that even people that are born blind have some type of visual perception, but they just have a hard time explaining what that vision perception is because they have never seen before.
Yeah, that's really interesting. So they might not have the words to describe what they're perceiving, but they're still experiencing some kind of vision.
Exactly. It's the imagination, and it's what Lucas does every day.
Blind people imagine vision. So when I am talking with you, I have in my brain an idea of what your face looks like.
Oh, that's so interesting. I wonder what he thought you looked like, and does he know you're a talking fish?
He doesn't. Now everyone does, though. Anyhow, Lucas said that people who had vision before they went blind, like he did, have a memory of what things look like. And that visual memory is key to his research.
So because blind people that have seen before have these visual memories, can we use these visual memories that they have in the process of restoring vision? That is my research. That is what I am personally interested in.
Oh, okay. So Lucas wants to learn how to switch on some very specific areas of the brain to make your brain picture something. So can he do that?
Well, Lucas said that when it comes to seeing where vision happens in the brain, there's a way to poke around and see what part of the brain is doing what.
What we can do as researchers is to send external electric activity and reactivate those parts of your brain.
Wait, external electric activity? Is that what I think it is? Is he shocking people's brains?
No. Okay, so our brain actually works because our bodies generate electricity through our cells. So Lucas is talking about sending a very low current to the brain just to sort of light up different parts of the brain that deal with vision.
Okay, that seems much safer.
So whenever we do this in that first region that is responsible for seeing curves, we can, in specific cases, generate an image of a curve.
Okay, so Lucas would send an electric signal into my brain and I would see a curve. He can do that?
Yep, without any signal coming from your eyes.
Whoa, that's like science fiction. But why just a curve? Like, what does that mean?
Well, Lucas believes that vision happens in what he calls layers. The layers are the steps that the brain goes through when it's processing what the eyes are seeing.
Okay, so it's kind of like putting a picture together in different steps. Like when you're drawing a picture, the first step might be that you make an outline.
Right. So Lucas's theory is that for vision, the brain sees the outlines first in curves.
So the first layer is, this is a curve. This is a curved object. But the first layer doesn't tell you if you're looking at an apple, or if you're looking at a ball, or if you're looking to something else.
So this layer is like the base that the rest of the picture is built on.
Yep. And so what this is getting at is that your brain is like always painting a picture one brushstroke at a time with lines and curves and then colors until you get the full image.
Oh, wow.
To restore vision in people who have lost their sight and want it back, scientists have to understand how to trigger these layers in the brain, but they're still on that first step.
The type of vision that we can restore today is basically those curves.
Okay, well, so how do you figure all this out? Like, if right now we just have the tools to draw outlines in the brain, how do you build like a whole paint set? How do you even figure out which parts of the brain you need to talk to?
Well, scientists like Lucas need to experiment to get more information, and they can do that by placing or implanting a set of teeny tiny wires in different areas across the brain.
What we can do is to put a little device, very, very little, smaller than a hair. We can put that into your brain, inside the brain.
Whoa. So what does all that do?
In the experiment Lucas told us about, they used the wire implant to test one part of the brain.
My research was sending electricity to this region called the prefrontal cortex and recording the activity in the visual area of your brain.
The prefrontal cortex is in an area that's important to our thoughts and behaviors.
And what we wanted to understand is how much influence does the prefrontal cortex have in the visual area of your brain.
This is like science fiction stuff. Okay, so they want to know, like, if we send a signal to this one part of the brain, does the vision section in a whole other area switch on? And that seems like a really, really complicated question.
Yeah, and it's also very specific. And sometimes this is how science works. You have to ask a specific question about a specific kind of curve or line in a specific area to make a new discovery.
Well, okay, so how did Lucas ask this specific question, and what is he looking for?
Well, in Lucas's case, he's listening, not looking. So let's start imagining that we're listening along with him.
Cool, okay.
For this experiment, there's a quiet, dark room with a monkey sitting in a chair.
Wait, so the scientist is a monkey?
No, the monkey is the test subject. So before scientists can test on humans, they test their ideas and implants on other organisms, from rats all the way up to monkeys, to prove that it's safe every step of the way.
Okay.
So scientists were showing the monkey different images on a screen and seeing how its brain reacted to different kinds of information. And the tiny implant was sending information to a giant computer in another room.
And this other room is chaos.
It's chaos because there's a lot going on in the scientist's room.
6, 7 people sit on that room, each one with 2 or 3 monitors. And you have headphones connected, you have several screens connected, you have several computers connected. All of this because this activity that you're getting from the brain is really, 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 really complex.
Okay, so there's like monitors everywhere that are showing the data, and what's Lucas doing in all this?
Lucas is using a computer program that helps him listen in to the data.
Oh, cool. What does that sound like?
You can hear what we call spikes. So basically, every time the brain sends or receives information, it does like a pop. Like electricity can be converted into sound. And we are also hearing the brain. We are hearing this tap that the brain is making all the time.
Wow, so that's what the brain sounds like.
Yes. When you convert signals from the brain into electricity and then into sound.
That's kind of cool. Like the brain is making patterns into rhythms of music.
Yeah, and if the pattern changes, then Lucas can hear what's changing in the brain.
So if you have pop, 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 and on the sudden you can have pop, 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 pop. Okay, the neuron is, the region of the brain is being less activated. Okay, what does that show? Oh, that shows that something is blocking it. Okay, what is blocking it? It's another region of the brain. And then we need to figure out what is that.
So while all the other scientists are looking at charts and graphs of the data coming in, and Lucas is just hearing that rhythm go pop, 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 up.
It's also a really powerful moment if you think about it, because you are listening to the brain. You are literally listening to the brain understanding something. This is not trivial. This is very, very powerful.
Lucas noticed something as he analyzed the sounds of the data in his head.
And my friend was showing different images to the monkey. And I started to hear a specific pattern in some situations. And I asked my friend what he was showing to the monkey. And it turns out he was showing images that were very heavy on curves.
Okay, so he's looking at pictures of curved things like apples, circles, maybe even a delicious cake with a crumb coat.
Exactly. The curved lines were causing activity in a particular neuron. That's the type of cell that sends messages in the brain. But Lucas was the only one who noticed this neuron.
It was so subtle that the graphics didn't show it.
Wait, so this tiny brain cell could only be heard, not seen?
Yes. And since only Lucas was listening to, rather than watching, the data, he was the only one who heard it.
I could only hear because of my hearing and because I was trained to do it, so I could detect that neuron activated in that specific situation.
Lucas told his scientist friend about what he had heard. He thought it could be proof for the idea that the first layer of vision sees curved lines.
In science, you need to have proofs of things for you to believe on it. So whenever I heard it, I'm like, all right, this is real. This is happening.
So they took a closer look at the neuron to find out if Lucas's hunch was right.
And we started testing, and we found out that neuron would only show that specific pattern whenever the neuron detected curves.
Oh, wow. So Lucas discovered part of the brain's language for curves. It's pop, pop, pop. It's a curve.
Yes, it's part of a big, complex language, but it's also the step to the next level, actually testing devices on humans. Lucas has imagined what it would be like to run those kinds of experiments.
You are in a room with a blind person and you send specific activity to the brain. And that person tells you that the person is seeing something that they hadn't seen for 20, 30 years. They're seeing a curve, they're seeing a line. That's very intense. And this is what I love about it.
Lucas hopes that someday his work could help improve people's vision or even restore vision for blind people who want that. But he says what's driving him now is learning and discovering more and more.
Whenever you find an answer to something, if that answer doesn't lead to more questions, it's not a good answer. Because there's always things to be discovered. And that's the beauty of science. Because science is a living organism. Science changes.
I think this has definitely changed the way that I think about vision.
Me too.
Now that you know how scientists study how vision works, try imagining an object in your mind and describing it to someone else. It could be an apple, a cake, whatever.
Use Lucas's idea of building vision in layers. First, describe the straight and curved lines that make up your object. Then add detail. Think about color and texture. What other types of details will make your object recognizable to your friends or family?
Or if you're able to draw, ask your friend to describe a picture to you, one layer at a time, and draw what you hear. Check whether what you're drawing matches the picture in your friend's mind.
We'd love to see or hear what you come up with. Email us at tumblepodcast@gmail.com with your experiments. Thanks today to neuroscientist Lucas Nadolskis, PhD student at the Bionic Vision Lab at the University of California, Santa Barbara.
Hear more from our interview with Lucas and the special bonus interview episode that's available to Patreon members who pledge at the $1 level or higher at patreon.com/tumblepodcast.
We'll also have more free resources on our website at sciencepodcastforkids.com. And if you want to ask a question for our show, email us at tumblepodcast@gmail.com. This material is based upon work supported by the National Science Foundation under grant number 2148711, engaging blind, visually impaired, and sighted students in STEM with storytelling through podcast. Special thanks to the team who helped with this episode, Dr. Peter Walters and Dr. Carrie Sapalo, and the rest of the team at Independent Science. Also thanks to Dr. Kelly Reidinger, Dr. Victoria Sellers, and Dr. Martin Storksteek at Oregon State University's STEM Research Center. Jason Struther did the interview and research for this episode. It was written by Mikal Richardson. Sarah Robertson-Lentz is our managing editor and designed the episode art. Chad Chennai is our assistant producer. Gary Calhoun-James is our engineer and mixer. I'm Lindsay Patterson, and I'm the executive producer of this show.
And I'm Marshall Escamilla, and I made all the music and sound design for this episode. Tumble is a production of Tumble Media. Thanks for listening, and stay tuned for more stories of science discovery.